Right, third situation when we're dealing with permutations. So this time, in our set of objects, they're not all different. So some of the objects, when we look at them, are the same. How do we deal with it? Well, let's break it down to simple cases and try and work out a pattern. So when we have two objects, if they were all different, I'd have A and B and B and A. So clearly there's our 2 factorial, two ways of doing it. If they were the same, well, there's only one, of course. A then A. Let's have a look at 3 objects. Okay, all different. ABC, ACB, BAC, BCA, CAB, CBA. 6, or 3 factorial, as we know. Let's make 2 of them the same. Now we only have 3. So our question is, let's look for a pattern. We've gone, when it was 2 objects, we went from 2 to 1. When we had 3 objects, we went 6 to 3. What have we done the same, if you like? What operation will go from 2 to 1, turn 2 into 1, but it also will turn 6 into 3? Divide by 2. Maybe that's more to the point, 2 factorial. If 3 is the same, then 6 goes to 1. That would be, if we're talking about division by 6. All right, let's have a look at 4 objects, see if the same pattern works. All right, there they all are. If we had 4 different ones, so 24. So we're expecting, if what you're saying is correct, if we have 2 of them the same, you said divide by 2 factorial, we're expecting 12 if we make 2 of them the same. Sure enough, we get 12. Well, 3 the same then, we would be expecting 4, yeah. Yes, indeed, we get 4. And obviously if 4 is the same, we get 1. So here's our pattern. If we have n objects, x of them are the same, then the ways we can arrange them is n factorial, and we divide it by x factorial, because what we're actually doing is we're dividing by the number of ways we could have arranged those x objects if they were different. Because they're the same, we're not concerned with how many ways we can arrange them, because they all look the same. So the number of ways of arranging all the objects divided by the number of ways of arranging the same objects if they were different. Okay, let's turn it into a problem. Letters in the word connorton. How many different words? Again, we're including nonsense words, using all of them. So connorton has 11 letters in there. There are 2 O's and there are 3 N's. So 11 factorial and 2 factorial, 3 factorial. So 2 for the O's, 3 for the N's. There we go. Here's an HSC one. How many arrangements of the letters in the word algebraic are possible? Okay, well, 9 factorial on 2 factorial. We've got 9 letters there and there are 2 A's. Part 2 though, how many arrangements of algebraic are possible if the vowels must go in the 2nd, the 3rd, the 5th and the 8th positions? So always look after your restrictions first. Let's place the vowels. Now, do we have 4 vowels only? Good, so we don't have to worry about any other cases. We're just going to use all the vowels, work out the number of ways they can be arranged. Then once we've worked out that order, we'll place them in the 2nd, the 3rd, the 5th, and the 8th. So that would be 4 factorial on 2 factorial. Now we'll arrange the rest of the letters, and that's 5 factorial, giving us a grand total of 1,440. 14D is what we're going to do.